Adding vectors geometrically. All right, we talked in the previous video about what a vector was. A vector is going to be a quantity that has a magnitude, so it has a length. It doesn't go on forever. It has a length and it has a direction. It goes in a particular direction. Um, and we are going to talk about these kind of freestanding, not on the coordinate plane yet. These are freestanding quantities. And what these are really used for heavily is physics. And I am not I am not a physicist. And I worry about putting things out on the internet that are then inaccurate physics-wise. What I can tell you is in physics, oftentimes vectors are representing forces. And if you take the sum of forces on an object, it'll tell you the overall force being applied to an object. So if an object is being a force, there's some force applied this way. That's maybe one force is pushing this way. And maybe there's another force pushing against the object and it's pushing that way, which is this one right here. The resulting force on that object is going to be the sum of those two vectors. So we care about adding vectors geometrically so that we can see what happens when we apply two forces to one another. So how you do this? It is head to tail is what you want to think, head to tail. Tail is where it starts, head is where it finishes, and you take the first vector, then you put the second vector down with its tail at the head of the previous vector. The actual answer is the vector that connects the two. It starts at the tail, ends at the head. All right, so let's do a few here. Draw the vector v plus w, then draw the vector w plus v. Are they the same? So I have this on grid paper to make this a little bit easier for us. I have this vector v right here. V is drawn by going down four, which by the way, very, very soon, I'm going to start writing this as like four down, four down, down four from the start. And then it goes left three or three left. W starts right here. It goes down 1, 2, 3 units. So this is 3 down. So 3D, 3 down. And 1, 2, 3, 4, 5 to the right. 5R. Get ready for this notation because we're about to start using that. So when I go to add these, right, I'm going to do a vector that for V, it starts here. I'm going to go down 1, 2, 3, 4 units and then left 1, 2, 3. And it's going to make that shape there. Right there. This right here is V. For W, it's going to, hold on, there we go. It's going to go down 1, 2, 3, and then right 5. 1, 2, 3, 4, 5. This is W. I'm now going to place these. I should have placed them to begin with together. Here's V. I'm placing the tail of W at the head of V. Move this. The resulting vector here starts at the tail of V and it goes, start at the tail of V and it goes all the way to the tip of W. This is the vector V plus W. This one is 1, 2, 3, 4, 5, 6, 7 down. And 1, 2 to the right. 7 down, 2 to the right. Let's do it. This is V plus W that we did right here. Let's do W plus V. So for this one, I'm just going to duplicate W over here. This guy is W. W goes, let's just make sure it's right. 3 down, 1, 2, 3, 4, 5 to the right. This is W. V starts with its tail at the tip of W. V is 4 down, 3 left. So 1, 2, 3, 4 down. 1, 2, 3 to the left. This is V. The vector that starts at the tail of W and goes to the tip of V, that's going to be W plus V. And these should come out to be the same. So let's see. It goes down 1, 2, 3, 4, 5, 6, 7 down. 7 down. And then it goes 1, 2, 2 to the right. So look at that. 7 down, 2 right, 7 down, 2 right. So it doesn't matter which order you add vectors together. It's the same with numbers, right? A plus B is the same as B plus A. They're the same vector. Same. Yay. All right, let's do a few more here. Right. Vectors, and we're going to do V plus W for all of these. We'll just V plus W. So we have vector V in this first one. It goes down 2. So this is 2 down. And I'm just going to draw that direction. And it's 1, 2, 3, 4, 5 to the right. W goes up 2 up, and it goes 2 to the right. So this guy is 2 up, 2 right. We'll just write that over here. 2 down. There's my pen. 2 down, 5 right. This is for V. This one's for W. Boom. All right. To do V plus W, I'm going to start by drawing V. So let me draw a little arrow guy. It's going to go down 2, 1, 2, right 5, 1, 2, 3, 4, 5. There it goes. There is V. And then for W, that's 2 up and 2 right. So, boop. All right, tail at the tip of V. We're going to go up 1, 2. We're going to go 1, 2 to the right. And the resulting vector is going to be our answer. So, boop, that guy right there, V plus W, goes from the tail of V to the tip of W, V plus W. So the standalone vector, right here, is what the answer is. You apply a force this way at that, and the magnitude tends to be the amount of force. So you apply a force this way, you apply a little bit force this way, it evens itself out to flat. All right. Let's see over here. I'll just use pink here. All right, so V, that one goes down 1, 2, 3, 4 units down, and that's all it does. Just 4 down, nothing left or right. W goes 1, 2, 3, 4, 5, 6. This is supposed to be 6. Pretend it's 6. 6 units to the left, and that's it. 6 to the left. So to do V plus W, I'm going to start V over here. Goes down 1, 2, 3, 4. That's for V. Then at the tip of V, or the head of V, I put the tail of W. W goes 6 to the left. 1, 2, 3, 4, 5, 6. W. And then the answer, the resulting vector, is the vector who starts at the tail of V and goes to the head of W. This is V plus W. Makes sense. You apply a force to the side, you apply a force down, you end up going down into the side. All right, last one here. We have V and W over here. V goes 1, 2, 3 up, and 1, 2, 3 right. 3 up, 3 right. W goes 1, 2, 3, 4, 5 down, 1, 2, 3, 4, 5 to the left, 5 down, and 5 to the left. 5 down, 5 to the left. I'm doing V plus W, so I will start right here. Hold on. All right. I'm just gonna put, I don't know, you're fine right there. 3 up and 3 right. So let's do 1, 2, 3 up. And then for W, putting the tail at the head of V. This one is, oh, what am I doing here? 3 up and 3 right. 1, 2, 3. There's V, duplicate. Now the tail of W goes at the tip of V. I'm going to make this one a slightly different color. Maybe I should make it like a, okay, that's what I'm gonna do. I'm making W a color because what's going to happen when we put the tail at the head of V, when we put W down, it's going to end up going in the exact opposite direction. It'll overlap that vector. So we have 1, 2, 3, 4, 5 down, and then 1, 2, 3, 4, 5 to the left, right? This guy right here, maybe I shouldn't have used blue. This is W. The black one underneath it is V. The resulting vector is the one that goes, and I guess I'll do this one in red. It's the vector that starts at the head of V, and it goes to the tail of W. So let me kind of show you what we have going on here. It's hold on. I was like, wait, that doesn't look right. Those forces should cancel each other out. Sometimes you have to think logically. Those should cancel each other out. The tail. You start at the tail. The tail of, so let's put everyone back together. We're starting with our at the tail, with the resulting vector at the tail of V. And then you start at the tail of V, then you go to the tip of W. So tail of V to the tip of W. That is the resulting vector. So here's what we have. This is the resulting vector. You apply those two forces together. You apply some force this way, some force this way. Most of it cancels out, and you're left with this guy right down here. This is V plus W. That is the entire answer. So if you apply those two forces together, that's what you get. All right, so that's adding vectors geometrically. On Alex, the tool's a little funky, and I'll be doing a separate video where I talk about that tool, but that'll be in a different video. All right, next video is subtracting vectors geometrically. See you then. Bye.